Hey guys, today we'll try to solve remove linked list elements. So given the head of a linked list and an integer val, remove all nodes from the linked list that has node.val equals val and return the new head. So given a head of a linked list, which is a list node, and a val, we want to remove all nodes of the linked list that has val and return the new head. Okay, first thing, we want to have a reference, like a pointer that points to the head, and at the end we want to return head. So what do we do here? First thing that comes to mind is we can traverse through the linked list, move on one at a time, and each time we meet the node, we want to check if node.val equals val, and if it is equal, we want to actually remove the reference to this node, which effectively means that you can just move the next pointer to the next. So for example, if for the first example, when we're traversing through 1, 2, 6, 3, 4, 5, 6, and the val for this example is 6. So when we meet 1, we do nothing, and when we meet 2, we do nothing. But then when we meet 6, we want to connect 2's next to 3. So since we're checking the node when we're actually at the node, and the operation we want to do here is to connect the previous node's next to the next of the current node, I think it's best that we have pointers that's pointing to the previous node so that we can connect to the next node. So we can initialize a prev that's pointing to head because that's the first element, and while dot next. So we want to traverse through each element in the linked list. But before we update the previous node, we have to check if the current val is equal to val that's given as a parameter, and if it is, we want to connect prev's next to current's next. And once this operation is over, we want to update the prev pointer to the Okay, I realized something. What I realize is, so if we check and if they're equal, and say we connected the previous is next to the next of the current. So for the first example, say we're at 6, and we connected 2's next to 3. In this case, if we update the previous to the current, there would be a problem because we effectively removed 6 from this linked list, but when we go to the next one, we're gonna run into problem because it'll try to link it back. So in this case, we want the prev to be 2 here, not 6. So here we don't want to move the prev pointer. So I think we can use an else here, and so if it's not equal to the value, we want to keep the previous pointer. Yes. And then we want to move the current to current.next. The problem I see is also this will actually remove the first one because prev should be none when it begins. Okay. I think this is kind of solid, but we can check the logic again just in case. So we initialize the pointer to head, prev pointer, and while there's next element, we want to check the current element against val, and if it is equal, we set the next pointer of the previous pointer to the next element. But if it's not equal, prev should move on. And then we traverse. I guess another thing to consider here is what if we run into like consecutive val that is equal to the parameter. So for example, if it's like 1, 6, 6, 6, and 2, what would it do? So on the second iteration, it'll find that it's equal to 6. So we'll connect this to next, and we actually won't do anything with the prev pointer and just leave it as is. And then we move on. And prev is still here. So we see that it's equal to 6. So we just set the next of this element to this one again, and then move on, and so on. Which I think will remove the 3 elements in the middle. Okay. Can't think of any edge cases here other than what I've just talked about. I guess if not cur, return. Oops, I meant head. Return head because head is none to begin with. And if we do this, since it iterates once over the linked list, it's all of n times time complexity, and the space complexity would be all of 1 because we're only setting pointers, and that's constant space complexity. Okay, we'll test this out. Okay, we ran into a problem. So non-type has no attribute next, which means here Okay, so we're not supposed to set it to none actually. Yeah, that was a mistake on my part because I'm actually comparing prev to anything, so it should be fine. So for example, if the first element was 6, something like this, it would check that it's equal to val, which means the prev will point to this. But that's not good, because, well, no, that's fine, because so let's imagine we're here. Prev is actually with our cur, and we check that it's equal to yeah. So I see the problem is if the linked list actually starts with the val, we might run into problem because, well, we'll first test out if, okay, it works for case 2. I mean, obviously, yeah, so it's not actually removing all the stuff, and I think we can change this to cur for the first case, because here we're not actually checking this one because the one after this one is null. So yeah, what do we do here? So for this one, let's try to simulate what happens when we go through this function. So 7, 7, 7, 7. So first we check the first node, and we see that it's equal to val, which means we set the prevs next to curs next. But in reality, it should just remove it. So let's set another example that's like this. So it's not equal, so prev stays. And when we go here, we don't want the prev pointer to move on. It's actually what happens, but yeah. Prev's not next. Let me think for a little bit. So so it's not actually removing the first element, and I suppose the first one, the only node that's left in my output here is from the first pointer that's referencing the head. But how would we remove this as well if everything is equal to val? So I think this code works fine as long as we just remove the edge case, like this one. So what do we do here? Maybe we can take another approach where we iterate only if current.value is not equal to val. Okay, we'll actually try to keep this code just in case and try to code it again, because I think we can do it like this. So if cur is not equal, so while it's not equal to val, so it runs only if okay, then there's a problem, because if we run this return, at the end there's gonna be a problem. Move on. Or we can just add one if statement at the end, I think. So after the loop is over, since even when there's like there's only values that are equal to target values, so for this input, the problem here is that we're removing everything except this one thing that we had at the beginning. So we can actually just add one more if statement, I think. That's checking whether head.val is equal to val, and if it is, we want to return none. This should temporarily solve this problem, but I'm not sure if it'll work in the grand scheme of things. Yeah, so now if we submit, let's see what happens. Okay, here's a problem. So yeah, it doesn't work for cases like this where, okay. Mm, it's not this. It worked, but barely. It has a terrible performance. So what I did was, since it fails to remove the pref pointer, I made a condition at the end so that if the first element in the linked list is equal to val, which is the one that we failed to remove, we're gonna return head dot next. I know this isn't the most optimal solution, but we did manage to solve it. Bye guys.